Welcome to Global Bytes Technology. Today we will see the topic that are mainly focused on introduction to electrical engineering is focused on understanding circuits and components. So let us dive into the course outline. So we will focus on mainly the overview of electrical engineering, basics of circuits, key components, applications, and conclusions. So let me start from the first topic. So as I said before, we will see introduction to electrical engineering. So let me start from the definition. So electrical engineering is a branch of engineering that deals with the study and applications of electricity, electronics, and electromagnetism. So it has many important points. So vital in powering and designing various electronics devices. So as you have seen in the picture, so there has two types of pictures. The first one is the power distribution system, and the second one is the person who designs robotics using a computer-aided design system. So another topic is basics of circuits. So a circuit is a closed loop through which an electric current can flow. So simply think the flow of water, right, into when we try to open up the water pipe. So we can easily so we can easily see the flow of water. So we can take as an example. Another one is types of circuits. There has two types of circuits: series and parallel circuits, and another one is fundamental elements: voltage, current, and resistance. So as you see, this picture indicates the power source that are connected to the load, so which is connected in series, and this is this is also the same as the first one. So we can easily see we can easily see this kind of example. So there are a lot of examples appear here. So in further for further information, you can ask me in the comment section, right? So the next one is voltage, current, and resistance. So voltage simply electric potential difference. So another one is current, the flow of electric charge, and another one is resistance, the opposition to the flow of electric current, and another one is Ohm's law. Right? So Ohm's law says that voltage which is equals to I times R. So we can take an example. So as you see in the circuit, we can easily understand what voltage means, right? And what resistance means, right? So the voltage, the battery, or simply battery is, by the way, battery is simply the collection of cells So so this is two cells connected in series. So we can say that this is battery, simply the battery. So V1 and V2. So which is connected to the resistor, right? Resistor, which is opposes the flow of electric current. So we can take analogy. We can take analogy of the water flow system. So easily, as you can see, this the flow of the water pipe, the water, the water flows through the water pipe. So uh, this this area in the volume is broader than this one. So if the broader or or the broader volume or area has low resistance, and the the and this one is also high, has a high resistance. Okay, types of circuits. So there has two types of or kinds of circuits that are that can be used as a separation. It is dependable on the type of circuit or the the required okay, the required the required circuit that are needed for us, right? So series circuits components connected in a single path. So as you see in this example, if this component and this component connects this leg connects to this leg in series, we call it series circuit, and another one is parallel circuit, components connected in multiple paths. For example, if this leg and this leg and this leg and this leg are connected in parallel, so we call it parallel circuit. So these are the key components of in the discipline of electrical engineering and electronics. So let me start from the first one, resistor. So the main purpose of a resistor is to limit current flow. So the flow of as we as we seen in the previous slide, we can understand the resistor purpose with compa- with compared to the water pipe water flow system. So the symbol of the resistor is like this, and the main color or the pictorial view of the resistor is like like this. So it has a color code, right? So this one is brown, and this one is green, and this one is red, and this is the tolerance value. If it is silver or golden color, so this color represents one, and this color represents five, and this color represents or simply it is multiplier, right? So 1.5 kilo ohm resistor, this is 1 kilo ohm, 1.5 kilo ohm resistor. So another one is capacitors. So the main purpose of the capacitor is to store and release electrical energy. Mainly, this is the main, the main purpose of the capacitor. So this is also types of types of capacitors: electrolytic, ceramic, and extra. So this is the symbol, and this one is the pictorial view. So as you see in the symbol, this one is the non-polarized fixed capacitor. So which is it is this one is polarized and this one is non-polarized. So and this one is also polarized and this one is also polarized, but this one is vary the depends on the given voltage or current. So this one is also the trimmer capacitor. It is the same as uh, variable capacitor, but it is used is different from the variable capacitor. And this one is the general polarized capacitors, and this one is the electrolytic capacitors. So the pictorial. So let me dive into the pictorial view. So this one is electrolytic capacitor, and this one is non. These three of them are non-electrolytic or simply non-polarized capacitors. So let me dive into inductors. So inductors, the main purpose of inductors is to store energy in a magnetic field. So remember, the inductor's purpose is different from capacitors, but they have similarities. But as you see, capacitors store and release electrical energy, but inductors stores energy in a magnetic field. So the main aim of inductors are to store energy in a magnetic field. So fake magnetic field or simply electromagnetic field will be created. So another one is symbol in the application. So the symbol, this one is fixed value inductor, and this one is variable, and this one is also iron core. So transformers also came from this kind of inductor, and another one is variac, and another symbol is tabbed. So this is the pictorial view of inductors. So another topic is diodes. So the purpose of diodes control the direction of current flow. The main purpose of the diodes are control the direction of current flow. So another one is types such as light emitting diodes, Zener diodes. So simply we can see the junction diode, Zener diode, tunnel diode, Schottky diode, varactor, diac, track, SCR, LED, photodiode. And this one is the pictorial view of the diodes. Okay, another one is transistors. It is the same as diodes, right? So transistors formed from or simply made from diodes, so two or more diodes. The combination of diodes create will create the transistor. So the purpose of the transistors are amplifying the switching electronic signals. In another one is types of transistors. We can or professionals classify transistors as NPN in the PNP. So simply, as you see, this one is NPN and this one is PNP transistors. So simply, in the NPN transistor, the input is given or given in the collector side. So this one is collector and this one is base and this one is emitter. In the PNP transistor, the given the given source is gated in a emitter side. So another one is the pictorial view of the transistor. So the next one is applications. So the circuits has many applications. The first one is electronics. So there has different types of electronics, which is consumer electronics, computers and smartphones. So as you see, this is clock, television, mouse, printer. So there has variety of electronic devices. Another one is power systems. So transmission and distribution of electrical power. So as you see in the picture, uh, this is the power plant and it goes to step up transformer. So the stepped up power source simply transmitted through power transmission towers, right? So another after that step down transformer. So the transmission power or the transmitted power comes to step down transformer. In the step down transformer also goes to sub-transmission systems, and these sub-transmission systems goes to step down transformer, and and also the step down power goes to goes to the supporting pole. So after that we can easily use this power source in our home, in the but in industrial or in industries it is different from the home. So directly directly the power taken from the distribution system. So because it needs the three phase system, right? Or two phase systems. In India, mainly two phase systems are implemented for industries, right? So another one is control systems, which is automation and regulation of processes. So simply to automate and regulate the process, right? So as you see, this is the purpose of or the application of electrical engineering in control systems. So conclusion. So we have seen four main things. The first one is definition and importance of electrical engineering, and the second one is definition, types and fundamental elements of circuits, and the third one is purpose, symbol and types of key components, and the fourth one is applications. So if you have any question, any query, you can ask in comment section. Thanks.